So what is hydrogen bonding? That will be the focus of this lesson. So hydrogen bonding, this will be the last intermolecular force that we'll be discussing in this series of organic chemistry videos. The first two we already discussed are dipole-dipole interactions and London dispersion forces. If you haven't watched those videos yet, check the description under this video and have access to the links of the videos we've already mentioned. Or better still, you can check our playlist on organic chemistry videos that we are working on. So you have access to dipole-dipole interactions and London dispersion forces. Also subscribe to our channel if you haven't done that yet, so you wouldn't miss future videos. So what is hydrogen bonding?
Hydrogen bonding is a type of strong intermolecular force that occurs when a hydrogen atom, which is covalently bonded to a highly electronegative atom such as nitrogen, oxygen, or fluorine, is attracted to the lone pair of electrons on another electronegative atom in a neighboring molecule.
This feels or looks very long.
Yeah,
it looks very long.
Yeah.
But let's make it so easy for our students to understand using ethanol.
Okay.
So we have two molecules of ethanol. So now look at the tail end of the ethanol molecule and see. We have OH bond. That is hydroxyl group. So OH, you see oxygen and hydrogen bond. So you see hydrogen is bonded to oxygen. And if you look at the definition of hydrogen bonding, we said hydrogen bond is a type of strong intermolecular force that occurs when a hydrogen atom which is covalently bonded to a highly electronegative atom such as nitrogen, oxygen, or fluorine. So in this case, hydrogen is bonded to oxygen, which is highly electronegative. And then the definition continues by saying that this hydrogen is attracted to the lone pairs of electrons on another electronegative atom in a neighboring molecule. Now, for the hydroxyl group, which is OH, oxygen is highly electronegative and has lone pairs of electrons. What do we mean by that? You can see that for the oxygens, we've shown 4 dots on each of the oxygen atoms. Those 4 dots stand for the lone pairs of electrons. Those lone pairs of electrons have not gone into bonding with any other atom. And there are 4 of them out there. Now, here is the interesting aspect. Why are they 4? You see, for oxygen, for it to become stable, it has to fulfill the octet rule. But look at this. For each covalent bond that oxygen has with hydrogen or any other atom, each covalent bond stands for 1 pair of electrons. And for 1 pair of electrons, we have 2 electrons in there. So for the highlighted blue bond, that stands for 1 pair of electrons. There are actually 2 electrons in there, 1 from oxygen and 1 from hydrogen. So we have 2. The next covalent bond, that is the one between oxygen and carbon. That is another 1 pair of electrons containing 2 electrons. So we have 1 pair between oxygen and hydrogen having 2 electrons. Another one between oxygen and carbon, 2 electrons. So 2 plus 2 gives us 4. And 4 plus the remaining 4 lone pairs of electrons gives us 8. So this explanation helps us to see that, well, oxygen has actually fulfilled the octet rule. I hope that's clear.
Yeah.
Good. So the lone pairs of electrons, although not shown earlier, actually are present in oxygen. So this is the actual presentation we have out there. So there is always a lone pair of electrons like this. Now let's revisit the explanation. Now oxygen is highly electronegative. What does that mean? Meaning it is much more stronger and will pull the shared pair of electrons it has with itself and hydrogen. So look at this. For the hydroxyl group, which is the OH group, the line, the black line with the blue highlights between oxygen and hydrogen has 2 electrons in there. Those 2 electrons, oxygen and hydrogen are sharing those 2 electrons. So hydrogen will try to pull the electron towards itself. That is the electron cloud around oxygen towards itself. But since oxygen is much more stronger and more electronegative than hydrogen, it will pull the shared paired electrons more towards itself, thereby distorting the electron cloud around hydrogen. And as a result, oxygen becomes partially negative and hydrogen becomes partially positive. Is that clear so far?
Yeah.
Sure?
Yeah, it is.
Okay. So as a result of this, there happens to be polarity in ethanol molecule. Oxygen becomes partially negative, while hydrogen becomes partially positive. Now let's revisit the explanation. We say hydrogen bonding. Hydrogen atom, which is covalently bonded to a highly electronegative atom such as nitrogen and oxygen or fluorine, in this case oxygen. The hydrogen is attracted to a lone pair of electrons on another electronegative atom in a neighboring molecule. So the hydrogen of one of the ethanol molecule, which is partially positive, becomes attracted to the lone pairs of electrons, shown by the blue dots, the blue dashes. So the hydrogen partially positive becomes attracted to the lone pairs of electrons on oxygen, which is highly electronegative. So the interaction or the bond that is existing between the first ethanol molecule and the second ethanol molecule through the attraction between the partially positive hydrogen and the partially negative oxygen is known as hydrogen bonding. You remember in an earlier video on dipole-dipole interaction, we said hydrogen bonding is a special type of dipole-dipole interaction.
Yeah.
Good. So if you look at ethanol, ethanol is a dipole. So the 2 ethanol molecules are dipoles. So this is also a dipole-dipole interaction. But this is a special kind of dipole-dipole interaction because it occurs between hydrogen and a highly electronegative atom. And for this highly electronegative atom, the ones we normally talk about are nitrogen, oxygen, and fluorine, or NOF. Or if you take it the other way around, fluorine, oxygen, nitrogen, phone. So keep that in mind. So this is a type of dipole-dipole interaction, but it is between hydrogen atom and a highly electronegative oxygen, nitrogen, or fluorine. In that case, we don't only refer to it as dipole-dipole interaction, but it is called hydrogen what?
Bond.
Hydrogen bond. Good. Hopefully this is clear, right?
Yeah, it is.
Good. But to end the lesson, we would like to talk about another molecule that also exhibits hydrogen bonding. For that, we'll talk about hydrogen fluoride. Hydrogen fluoride is a molecule formed between hydrogen and fluorine. For hydrogen, it has 1 electron in its outermost shell, but it needs to fulfill the duplet rule by having 2 electrons to become stable. But the fluorine has to satisfy the octet rule, meaning how many electrons should it have to become stable?
Only 1.
Good. So it needs 1 extra to add to the 7 it already has to become stable. Because if you count the number of electrons fluorine has, it has 7. So 7 plus 1 gives us 8. And hydrogen also needs only 1 to become stable. So none of them will be willing to give. So what will happen is they will now come together, overlap to share 1 pair of electron. So hydrogen becomes satisfied. Fluorine also becomes satisfied. But here's the interesting aspect. The shared pair of electron, hydrogen will try to pull it towards itself. But fluorine is much more electronegative and stronger, so it will pull the shared pair of electron more towards itself, thereby causing the hydrogen to become partially positive and the fluorine becoming partially negative. So we end up having a dipole in hydrogen fluoride. It doesn't end there. Suppose you bring another hydrogen fluoride close to the first hydrogen fluoride. The same process repeats. They overlap in covalent bonding. Hydrogen tries to pull the shared pair of electrons towards itself, but fluorine is much more electronegative, so it pulls it more towards itself. So hydrogen becomes partially positive and fluorine becomes partially negative. But it doesn't end there. You see that the fluorine, which is partially negative, and hydrogen, which is partially positive, now have some kind of interaction between them, some strong force of attraction between them. This force of attraction is known as hydrogen bonding. So take note of this. Hydrogen bonding is always between hydrogen and either nitrogen, oxygen, or fluorine. These are highly electronegative atoms. Difficult or easy to understand?
Very easy to understand.
Really?
Yeah.
Okay, so let's look at some properties of hydrogen bonding.
Alright, so looking at the properties of hydrogen bonding, with the hydrogen bonding, they are stronger than regular dipole-dipole forces, but they are weaker than covalent or ionic bonds.
So that's why we said hydrogen bonding are special type of dipole-dipole forces. So they are stronger than just the regular dipole-dipole force. So we put them under one category on themselves, hydrogen bonding. But I repeat, they are a type of dipole-dipole force. Then the next one is what?
Another property is that hydrogen bonding only occurs when hydrogen is covalently bonded to nitrogen, oxygen, or fluorine.
Good.
And sometimes very weakly to other electronegative atoms.
Yeah, which is very rare. So keep this in mind. Nitrogen, oxygen, fluorine, NOF. Or fluorine, oxygen, nitrogen, phone. So if you have that in mind, know that hydrogen should be covalently bonded to one of these, and then have an interaction with another molecule that is also having similar properties.
Another property is that compounds with hydrogen bonding have higher boiling and melting point than expected for their molecular size.
Good.
Example, we have water.
Good. So water has hydrogen bonding. So I repeat, hydrogen bonding is a type of dipole-dipole force, or having dipole-dipole interaction, but it is much more stronger than just the normal dipole-dipole force. That's why it deserves a whole category on itself. So this brings us to the end of the discussions we have on hydrogen bonding and then also intermolecular forces. If you haven't watched our previous videos on intermolecular forces, that is dipole-dipole interaction and London dispersion forces, you can check the description below to have access to those videos. Or better still, check our playlist on organic chemistry to see those videos. In our next lesson, we'll be discussing the general properties of organic compounds. These are also going to be sets of videos. We'll be talking about solubility and also boiling and melting points. But we'll start off with solubility. So subscribe to our channel so that as these videos are recorded and released, you wouldn't miss any important updates. See you in our next lesson.